Hello, Bismillah ar-Rahman ar-Rahim. Hello everybody, I would like to introduce myself. My name is Adnan Akil, a PhD candidate student in Missouri University of Science and Technology in the USA. Today I'm happy to be with you to go over this lab and through its steps. So please pay me your attention for your benefit. This lab is easy but needs you to go through it step by step. Now please be ready to start work on this lab. Lab number 1. Go to open the internet window and go to the site GPL Spectral Library website at speclib dot jpl dot nasa dot gov and then press enter. As you see in this window, so go right now, click on search, either by clicking on search button on the menu bar hey, or by clicking on search folder on the navigation submenu on the left. A new window will appear showing different classes of materials. As we see, minerals, lunar, vegetation, rocks, meteorites, water, snow, ice, soils, man-made. Each class has a number which indicates the number of materials that this class has. For example, minerals class has 1748 samples, while man-made class has 84 samples. We're gonna start with minerals. So creating the reflectance spectral curve, this is the first part we're gonna do. So first we will create the spectral reflectance curve of quartz, then hornblende, and then finally olivine, respectively as samples from mineral class. So select the class of minerals by clicking on it. A mineral search web page will appear. What you need is just to enter the name of a quartz and nothing else. Click search button here or run query and some other websites button. Please note that this button is not as the same as the search folder. This is different and this is different. This is for classes in the submenu, and this search button is just for specific minerals or material. So click on it, search. Okay, a search results web page will appear showing Aster Spectral Library mineral search results of the quartz. So now click on under in the plots column, click view plot. So another web page will appear showing the spectral curve of the quartz in the range between 0 and 25 micrometers. So now on this window, as we see, there are two options. The first is view data file on the left, as we see here, and the other option is interactive graph. So click just on view data file. One click, and then as we see, So another web page will appear which contains all the spectral data including the wavelengths X and the reflectance percent Y of quartz mineral. All the data, the name, the type of the material, the class, the subclass, particle size, number, and the owner, and all these things. And as we see here, the wavelength and the reflectance. The wavelength is the first column on the left in micrometer, and the other column is Y, which is the reflectance percentage. So we need to save these information or data. To save this data, go to the menu bar and click on File, then Save As, and then try to save it in a folder which you like, where you like also. So let's, for example, just save it, and we'll make it easy, and just, and let's say in D folder, create a new file, and let's say just remote sensing lab 1, and then click on it, name the file, and let's name it as quartz mineral. Okay, be sure please to save it as text file. Look in this text file, and then save. Now all what you need is just close this web page and launch or open the Microsoft Office Excel. Go from start menu, go to programs, Microsoft Office, and then open Excel program. On Microsoft Excel, so click, go to file and navigate to select it, to select the saved quartz text file for Windows 2003, and list, or go to the button Office. This is Office button for Windows 2007, and click on it, one click, then click on open and navigate to the folder that you have already saved. My computer, we saved it, and folder D or drive D, and folder remote sensing lab number 1, and then files of type, be sure to make it text files. Now it's here already. Click on it and click on open button. Okay, a text import wizard, steps 1 of 3 window will appear. Make sure to activate delimited, activate please, and then click on next button, then next again, and then finally on finish button. So all the data will be posted in this sheet. Now we will create the spectral curve of the quartz mineral. However, for this lab we only need the spectral range between 0.4 and 3 micrometers. So we will do the following steps. Look, so this is X, column A is X values, which is the wavelength, and column P is the reflectance, as we said. But we need just the wavelength or the reflectance of the wavelengths between 3 and less. So let's go and try to find these values. It takes a little bit time, but it's okay. So you will plot your data using XY scatter with smooth lines connecting data point. Just plot data only between desired values, which are 0.4 and 3 micrometers wavelengths. As we said, in this plot, the x-axis represents wavelength in micrometers, whereas the y-axis represents percentage reflectance, P column, as in the Excel sheet. So takes some time. Now it's, yeah, almost we are closed. Okay, that's it. This is the values. So this value is gonna be the first. So the best thing just to make it in bolder font and in another color, so it be easy to catch it and see it. And now I'm gonna just create scatter diagram or curve. So select these values and go again. All these values have to be selected and included in our curve. So it's gonna take some time, but we have to do this. So be patient. Now we have been selected these values in the range between 3 and 0.4. So this is the lowest value, which is 2 point something, and the highest value was almost 3. So now click on insert button and the magnifier, and then on scatter diagram, or so click on the arrow and then choose this curve. Now we will make some adjustment for this shape to look very well and good, and to be easy to understood, and to be easy to explain, to extract some information from this curve.